So in general properties of waves, we discussed that there are two types of wave. The first one is related to longitudinal, and in longitudinal, we have one chapter that is of sound. That is very short topic. And for transverse wave, we have two different chapters. One is of light. Light is a detailed section, and the second one is of electromagnetic spectrum. So today we will start with chapter light. And for light, the basic property you already know that light is transverse in nature and light does not require any medium to travel, right? So basically, light is transverse in nature and no medium required. If we take the example of the sunlight, so sunlight travels from sun and there is a huge vacuum and a space between earth and sun. So light can easily travel through vacuum also. But if we compare with sound waves, so sound wave is not able to travel in the vacuum, but light can easily travel without any medium. Okay. And the third important point is related to the speed of light. So we represent a speed of light with a symbol c because it is a constant value. It remains constant everywhere. And we can also say that light is a universal constant. So the speed of light remains everywhere in whole universe. So light is a universal constant. So that's why we used to write the symbol of a speed of light with c, and the value of this speed of light is 3 into 10 to the power 8 meter per second. So this is the first concept. And second, if we talk about the further properties of light, so the very first concept related to light is reflection of light. And there is a law which is known as law of reflection for light. And in previous chapter, we discussed about the properties from the ripple tank that waves can reflect, refract, and also they can diffract. So there are three possible processes. So the first process is related to the reflection, and reflection, you know that the angle of incidence remains same for is equals to the angle of reflection that we studied in the previous chapter of the waves. So same law applied for the light, that angle of incidence will be equals to angle of reflection. So there are two basic postulates for law of reflection. The first one is the angle of incidence.
Well, angle of incidence will be equal to the
Reflection,
angle
yes.
reflection.
And we all know that how to measure the angle of incidence and reflection. We will also discuss further in this chapter. So in exam, if they ask about to write down the postulates for law of reflection, so there are 2 points, two postulates for law of reflection. The first one, we already know that angle of incidence is equals to angle of reflection. And again, if we consider the reflecting surface, so let's suppose we are having a reflecting surface and light strikes from one side. We consider any random angle for the angle of incidence. Let's suppose this is angle of incidence. And first of all, we have to draw a normal line. This is normal line. And normal line is always perpendicular to the surface. You can see there is 90-degree between the reflecting surface and this normal line. So normal will always perpendicular to the reflecting surface, and when light strikes the medium, so it will reflect back with the same angle. So with the help of this normal line, we can easily mark the reflected ray. So basically light incidence from left hand side. This is called incident ray, and this is the angle of incidence, and the other one is the reflection. This is angle of reflection, and this is reflected ray. And the central line is known as normal ray. So this is the basic idea that we already discussed from, already derived from the ripple time. So the second postulate is related to the all rays which we are using in law of reflection. So the next postulate is incident, normal, and reflected ray. So we have three different types of ray in law of reflection, and all rays lie in the same plane. And basically in the diagram, you observe that all rays are between X and Y axis, right? There is no concept of Z axis. So the second postulate explains you that all rays must be in same plane. So we are using XY plane. We are working on XY plane. So all types of ray lie in the same plane, right? If you consider that any one ray will move in Z axis, so other two are not moving in Z axis. So that is not possible. If you are working on XY plane, so all rays must be in XY plane. If you are using YZ plane, so all rays must be moving in YZ plane. So this is the concept of the second postulate, right? When we are using single direction, so we use the word axis. And when you combine two axes, so that will give you the concept of plane, right? So on
Right.
paper, we are using XY plane because that is simple to identify and simple to draw on the paper. But let's suppose in few conditions when we discuss about advanced concepts, so sometimes we also use the Z axis, but not in the light chapter right now because we are learning the basic concept. So that's why we only consider XY plane in our syllabus. So these are two postulates. So whenever they ask about law of reflection, so always remember these two postulates. And the concept of diagram is very simple. So this is the first idea related to the light, that is reflection of light. And if you think about your normal daily life example, so any application that is related to the reflection of light in your daily life, if you consider, or any example that is
A light bulb?
a light bulb, okay. Basically any object you can say, or any component or any instrument that we use for reflection, that is a very common daily life use component which we use for the reflection. If you consider the example of mirror, right? So basically we use mirror in our daily life for reflection of light. When you are standing in front of mirror, so light strikes the mirror and then reflect towards your body, and then we are able to see the object in the mirror. So basically mirror use the law of reflection of light. So with the law of reflection of light, mirror is able to maintain the picture of an object on the mirror, right? And there are a few concepts related to the plane mirror. We are only talking about plane mirror, no other type of like spherical or curved mirror, because plane mirror is only included in our syllabus. So we only discuss about plane mirror. So when we are talking about plane mirror, so in the concept of ray diagram, there is a different idea that how to draw the ray diagram on mirror. We know that when we shine light on the mirror, so light will not travel on the back side of the mirror, right? Because there is a polished side on the back side of mirror. So light will completely reflect back from the front side. No light will move on the back side of the mirror. But when we are drawing the ray diagram for plane mirror, so that is slightly different from the normal idea. So let's suppose if we consider the concept of plane mirror. So for reflection, we have only one concept that is related to the mirror image. Because in this chapter, we will also learn about the lenses, and there are two types of lenses included in your chapter. So then after learning all the concept, there will be some confusion in lenses and mirror. So that's why you have to know about the clear idea that how the mirror works with ray diagram and how the lenses work with ray diagram. So let's suppose if we consider a surface of a mirror. So let's suppose this is our surface of mirror and the backside of mirror is completely polished. So this side is polished, and let's suppose object is placed over here. So this is our object. And if we consider two rays coming out from this object, let's suppose we consider two different rays that are coming out from the object. One strikes at this point, and the second ray strikes on the other point. So there are two rays, let's suppose, coming out from the object after the reflection. And normally what happens, according to the law of reflection, we will get the same angle light on the same side. Like if you make a normal line over here, if we make normal here, and we will also make normal here to identify the exact angle of reflection. So you will get angle of reflection by using the same angle. So this is the angle of reflection and this is the angle of reflection. So basically, this is the observation from the plane mirror. Okay, now what is the difference in the mirror image? Basically, we know that the back side is completely polished. This is polished side. And when we are using polished side, so it means that light will not travel on the backside of the mirror, but only for mirror image, we have to find out the point where these light rays intersect each other. So when the light rays intersect each other, so according to the ray diagram, when light rays intersect each other, so we will get the image of an object. So you will get your image over here only for the mirror diagram, only for the mirror image. So you will get image on the same level on the other side. And we have to draw dotted lines and from the next ray. So you can see now that when light ray is incident on the mirror, so we use dotted line. These dotted lines are just for the mirror image or the ray diagram. We know that this is not possible in real, but if you consider the angle of incidence and angle of reflection, so definitely you will get the same angle. Like if you measure this angle and this angle, so let's suppose if you consider this one as angle of incidence, so this is your angle of reflection. And if you consider this one as angle of incidence, so this is your angle of reflection. And if you also measure the angle from here, this is incidence, this is reflection. So just for the ray diagram, we have to make image over here. So this is our image and this is the object. So in MCQs, when you got the question from mirror, so most of the time we mark image over here, right? So for mirror diagram, never mark on the same side of the mirror. You have to mark image on the other side of the mirror, because from the ray diagram, because we are working on paper, we are not performing from real mirror on the paper. So on paper, when we are working with ray diagrams, so you have to make a reflected ray on the other side. That's why we use dotted line, because that dotted line is not real, that is virtual picture of the image on paper. And mathematically you will get the same angle on both sides, incidence and reflection. You are getting same angle on both sides, and this white line represents plane mirror. Any confusion in ray diagram?
Wait, so just to confirm 1 second,
Hmm.
these two incident angles are different, right? They're not the same.
Yes, these incidence angle are different because there are multiple light rays coming from the object, right? We only consider two of them.
And what about the
Hmm.
reflected angles?
Basically, reflected angle will be equal to that individual incident angle, right? It
So they're
depends
not equal
upon.
to each other.
Basically, for individual ray, the
For
angle of
example,
incidence
these
will be
two.
equal. Let's suppose if we mark them 1 and 2. So let's suppose this is the first ray and this is second. So the angle of incidence of first ray will be equals to the angle of reflected ray in the ray diagram. Sorry, this is equals to 1. And you will get same angle over here, right? And these yellow lines will also show you same angle, right? Those regular
Yeah.
lines actually shows you the real picture, because in our normal life, if we just place mirror somewhere and we just strike laser light on it, so laser light will reflect light with the same angle. But just for the ray diagram, we used to draw lines on the other side to get the exact position of the image and exact angle of it. But you will get the same angle if you measure from the same side or if you measure from the other side. Okay.
So these two angles that I circled, are they equal or not?
Yes, they will equal because we are using law of
Oh,
reflection.
okay. Okay.
When
Thank you,
we
sir.
solve the question, so you will get the clear idea that how to make the angle, because right now we are not marking the angle exactly, but according to law, we will apply that law on the question. So always remember that you have to mark image on the other side, not on the same side. Options are also available in paper, like A, B, C, D. So one option definitely will be on the same side, but you have to follow the ray diagram. And if they ask about the property of image or the nature of the image, in question they also used to ask that write down the property or write down the nature of image from plane mirror. So if we talk about the nature, or if they ask about property, so we have to write a few properties. The first one is, okay, now there is a concept of real image and virtual image, right? So real image means if you are getting the same picture of the object, exact the same copy picture on any reflecting surface, so it means that image is real, right? And according to the ray diagram, what do you think if we talk about this image? Because this is our image from plane mirror. So this image will be real or virtual?
Which one? The image?
Yes, the point
So
where we
that's
Virtual.
write
virtual.
image, so that is
It's
virtual. We know that, and if you consider the real example of the mirror, so when you stand in front of the mirror and when you move your right hand, so in mirror, which hand you feel that it is moving on the mirror, right or
The
left?
left one.
Left one. So
the left
basically
one.
mirror actually shows you virtual image. Actually you are moving your right hand, but mirror, in mirror it is showing that we are moving our left hand. So that's why in mirror you will get virtual image. So the first property is that you will get virtual image. And the second property is, if we talk about the size of an object. So what do you think that size of an object will be equal to size of image, less than size of object, or greater than size of object?
Wait, can you repeat?
The same items.
Let's suppose again, if we consider our example when we are standing in the front of mirror. So what you feel about the size of image? Your size of
It's
image
the
will
same.
be equal. Yes. So again, we feel the same size because
Equal.
it is plane mirror. So there will be no changes in the picture or in the image. So we will get equal size of an image as compared to object. And one more important thing, if we place any object, so right and left is inverted. Your right side will shift towards left in mirror, and your left side will shift towards right. But if we talk about up and down side, so up and down side remains same, right? Your head will be on the top level and your foot will be on the lower level. So it means that your image will be upright.
Upright.
Upright means we are talking about vertical orientation, not horizontal. So upside will be on the top, lower side will be on the bottom. And if we talk about right and left orientation, so for that we use the term laterally inverted. And the meaning of laterally inverted is very simple. If you consider letter F on the mirror, so that will be like this. So your right will shift towards left and left will shift towards right, but upside and downside will remain same. And one more property, image and object are equidistant from mirror. You can easily identify the distance if you take the reference from the distance of an object from the mirror. And if we take the distance of an image from the mirror, so your image will be on the same distance, just like the distance of an object from the mirror. So while we are working on the ray diagram, so always remember we have to make on the same distance. Most of the time they gives you some options in the picture, and they will never ask like to draw the complete diagram by yourself, but maybe in old past papers you will get some questions in which you have to draw a diagram by yourself, points are given. So this is the formation of the image diagram from plane mirror, right? Any confusion?
No.
Okay. Okay, this is the question for the mirror. So now you can see this is our object, and they are asking at which position is the image formed. Okay, one answer I got is B, and O is your object. So we have to use the same concept of the mirror, right? So we will get image over here because it is at the same distance from the mirror, and light will also reflect towards the point B. Okay. So most of the time they ask about different concepts, like mostly they ask from lenses, but somewhere they ask about the plane mirror, because in plane mirror we have only a concept of plane mirror. There is no concept of the curve mirrors. So that's why the concept of mirror is very easy. And if you consider this 31 question, so the diagram shows a ray of light directed at plane mirror. So again, we are using plane mirror, and angle of incidence is, or the angle in the picture is given is equals to 40.
A. A.
Okay, option A, and one answer I got is D.
Wait, no, no, no. Wait, my bad. It's
Yes.
D. Yeah,
So
it's D.
most of the time we just get the reference from the angle given in the question. So we have to make a normal, and we when you make normal, so you realize that we have to measure this angle. So yes, D is your right answer. Your angle of incidence is actually 50. They just confuse you by giving the angle on the other side, because we feel that question is very easy and just we quickly take on 40-degree angle, but this is 50. So first of all, you need to identify correct angle, and secondly, you also need to apply the law of reflection, that angle of incidence is equals to angle of reflection. And one more question, like from the mirror also. Again, we have an object in front of a plane mirror. So which diagram correctly represents the image I formed by the mirror? Option A, right? So it is also very easy, because there is only one confusion. Most of the think that C is the right answer. But according to the ray diagram, we studied that we will get the image that is from the same distance from the mirror. So C is not possible. And B actually shows you inverted picture.
Uh,
So that is also not.
Vertically opposite.
Yes. So in this way, there are a few questions related to mirror, but this is very easy. And the properties we already discussed. So if they ask about property somewhere, so you are able to answer that one also. So the first concept is